All right, let's get started then. So, we designed a Raspberry Pi bot to play a game called Keep Away. We bought a Raspberry Pi kit that came with all of the external parts that we needed. We have the rover try to stay around half a meter away from the object in front of it. The sensor loses sight, or if the sensor loses sight of the obstacle, then it will turn 360 degrees in an attempt to look for it.
So we ran into a bunch of problems trying to get this thing to work. One of the biggest was mainly a debug issue, and it was trying to connect the Raspberry Pi to the CSU's network. And it turned out that the Raspberry Pi's integrated network system doesn't communicate well with CSU's. I was only able to connect to the CSU guest network, and even then, it wasn't able to uh, really work on that network well. So we ended up having to connect it to a monitor and connect it to a mouse and keyboard on campus in order to kind of debug and work through some of the issues.
The next largest issue we encountered was downloading all of the dependencies for the overall program and getting it to work. There are over 30 files required to make the entire car run appropriately. Specifically, the various code was not communicating properly with the hardware and the on the car and required additional testing to get it working. In order to get all dependencies to work, we needed to Google various other projects in order to troubleshoot our problems. A solution we found was to first initialize communication from the car to a local server. This initialized all the motors and operations and allowed the different components to talk to one another. After this, it was simple to test and troubleshoot each component individually in order to make sure it worked. One of the indicator lights on the car was not working properly, and it was determined that the connector was not properly seated in the receiving fitting.
Another problem that we ran into was writing the code to make the different servos or motors work. In order to kind of troubleshoot that, we had to look for different files that came with the robot and see what those files required or what different imports that they had. So, for example, to make our program work, we had to import the ultra.py file, which include all the different code to make the ultrasonic sensor work. And from importing those different files into our keepaway.py file, it was able to make the car physically move and play the game that we wanted it to play.
A minor inconvenience was the power supply to the car. It runs off of rechargeable lithium ion batteries. However, after the batteries were drained, a lithium rechargeable battery pack was required to restore the charge. Gathering the material for this project was more expensive than originally intended. Additional component cables were required to purchase in order to properly diagnose different components on the car. Because of these expenses, we were not able to purchase a rechargeable battery pack. While this did not result in a major roadblock for the project, it did prove to be inconvenient. The power supply that came with the Raspberry Pi was only intended for the Raspberry Pi board and not additional components. Because of this, the Raspberry Pi gave a constant warning of low voltage, though this did not seem to severely impact the project overall. This did prove to be massively inconvenient. However, the cable attached for the power supply is only about 2.5 feet long, meaning we could only test the car's ability to move in a distance less than that of the charging cable. Further funding, or if further funding was available, an unattached car could have greater functionality and could be tested easier.
Another issue that we ran into but wasn't massively impacting the project was there's one motor that wasn't functioning correctly, and that was the motor that controls the rotation of the head. So to get around this, we just implemented in the code for the wheels to turn left or right rather than moving the head left or right. In the future, we could further diagnose the problem and see if we could get that motor to work correctly.
Building a rover provided us with numerous difficulties that popped up every step along the way, especially when considering how to connect the rover so all of us can work on it simultaneously. Getting the libraries we needed, how to write our own code, dealing with power supply, and the head servo not rotating. This project was relatively simple and mainly required to assemble many pieces for the greater goal of having a fully functioning rover. Most of our experience with computer science up until this point was completely digital, writing lines of code to get lines of output. However, this was completely different, allowing us to learn the basic skills of how to connect the code we are creating to an external and physical object to see our code actually interact with us.
It was so much more enjoyable to work on something that felt more tangible. Although our program is relatively simple, now that the basics are figured out, with enough time, we could individually code an algorithm to get the rover to race or stay on the track or avoid obstacles. Here I'm SSHing into the rover from my laptop. And now I'm running the program that we wrote. And as you can see, as my hand moves towards it, it backs away, and then whenever it detects that there's no object in front of it, it moves forward to detect the object. And because of the charging cable, I could only leave it on my desk because that's the distance the charging cable would reach. That's the data that's given from the terminal. The citations, the Mars rover website. That website includes all the dependency files that we had to download into the rover to get it to work, and it also includes all the information on how to build the rover.